It's true.
All right, differential calculus impromptu review. We've got a vertical asymptote and possibly some holes to consider. Let's analyze this function. The first thing to do anytime you have a rational function is factor the numerator and denominator. So the numerator factors as x minus 10 times x plus 10. And I'm guessing the denominator factors as x minus 10 times x minus 8. Negative times negative is a positive, and then add them together. Yeah, that works out.
All your numbers are right, is wrong.
So right here, since I have the same factor top and bottom, that means there's a hole in the function at x equals 10. Holes are when you have a zero top and bottom, right? Because you can cancel them out. So the original definition of the function isn't defined, but if you cancel that out, the rest of it works fine. Yeah. So what we would find is, although that f of 10 does not exist, if you take the limit using this definition over here, the limit as x goes to 10 of f of x is going to be equal to what, 20 over 2 or 10? Yeah, so it has a limit, but the function doesn't exist there, so that's what we call a hole. Okay, and it's also a removable discontinuity because we could plug that hole if we wanted to by redefining the function at 10 to be 10. That fills the gap. Otherwise, come on, pen. This factor right there means we have a vertical asymptote. So there's a vertical asymptote of x equals 8. And I think that's all we were asked about.
So the other one would be the vertical asymptote?
There is not a slant asymptote here because the degree of the top and the degree of the bottom are the same. What were we saying, Daphne?
So the hole is the one that's the same, and then the asymptote is the other one?
Yeah.
The denominator?
Yeah.
I just think.
And this has a horizontal asymptote. As x goes to infinity, it would be the leading coefficients, which would be 1 over 1 or 1.
I just think vertical asymptote is the bottom because as it approaches that 0, the denominator gets infinitely smaller until it reaches 0. So it's getting.
So both pieces of the denominator mean, but the numerator doesn't matter.
I have to remember big on bottom, small on top, and one.
Yeah, so there's also, the question didn't ask this, but there is a horizontal asymptote. And there is a question that's likely to be on the exam where I say, tell me everything you can about this function. Asymptotes, maxes and mins, concavity, inflection points.
Is that the little quiz that you did?
Like the quiz I gave, yeah.
I'm going to do that.
Is there a problem like that on
the sample? There's 2 on the sample.
On the sample?
Yeah.
I have a question.
And there's at least 1 in the review too.
Am I going to have to graph a problem?
You are going to have to graph at least once.
Ooh, I will bring a ruler.
Next question is number 32. Oh, I guess I should submit it, huh? Get a green little button. Yay, I get a green button. All right. 30. Man, I assigned 61 problems.
Yeah.
Oh, my vicious.
It's kind of
so,
whack.
It doesn't count your grade, though, does it?
No.
I don't know.
Yeah, so you can just do whatever you want.
It says it doesn't.
Yeah, I'm pretty sure it doesn't. I'll double check that. All right, so here we have the water leaking out of the conical tank problem. This is a tough one. All right, so.
Okay, what does it mean by inverted?
It means just pointing down.
Oh.
Yeah.
Okay.
That's all. Screenshot. Data. All
I
right.
thought when I meant inverted, it's like turned inside out. And I was like, how does that work? It's like, this is
This is
an inverted cone right there. Right there. Okay, so we have water leaking out and water being pumped in. Okay, so for the change in volume over time, we've got a minus 14200, and then we're pumping water in at some rate. I'm just going to call that R. So plus R, and they don't tell us what the rate is. That's what we need to figure out. Find the rate that it's being pumped in.
might not want to use R.
Because there's a radius.
Oh, there's a radius. Okay, we'll call it X then. Call it W for water.
It's so perfect.
All right, call it W.
I have a question.
What?
How many of like ones that we have to set up are going to be on the test?
Like this?
Like, or like there's the
Related rates?
related rates, and then there's the
There's not enough time to do more than like 2 of them.
So there
But
will be
there's
no.
also the optimization.
Okay, anyway, the tank has a height of 13 meters. So we got 13 meters that way, and a diameter across the top of 5.5 meters. And the water level is rising, so that would be dH dt at 200 centimeters per minute, which
20.
we should turn in, or 20, yeah, sorry, I don't know why I said 200. Because I was thinking about converting to meters by dividing by 100. So that would be 20 over 100 meters per minute. Because you want to have everything in the same units, and there's meters everywhere else. Okay, when h equals 4.5 meters.
It's in cubic centimeters.
Okay, what's that?
It's in cubic centimeters.
Wait,
Oh, the water is being pumped in cubic centimeters. Oh gosh, maybe we should change everything else to centimeters then. Yes, let's do that. Okay.
But why don't you
so,
just change it at the end instead of changing all of them right now? You just change one number at the end.
Well, this number here is in cubic centimeters.
Oh, okay, that'd be 2 numbers.
Cubic centimeters. And then
Yeah, I think I want to change everything to centimeters. So then this would be 550 centimeters. This would be 1,300 centimeters.
and then just
This
get
would
rid
be 450
of
centimeters.
the fraction.
And then get rid of that. I think that's better. Yeah, so double check your units on these for sure. All right, so next we need a volume equation to work with. So volume of a cone
would
is
you give us?
1/3.
Would you give us this on the test?
Yeah,
Okay.
1/3 base times height. So yeah, I'll give you any formulas like this you need. The setup's the hard part, not the formulas. All right, so we have 2 variables here. That's a problem. So we'll use the shape of the cone to get rid of a variable. So if we just look at the ratio of height to radius, then I get 1,300 compared to the radius is 225. So then the height is equal to 1,300 over 225 times the radius.
Where'd you get 225?
Half of the diameter.
Gotcha.
And I'm sure that reduces quite a bit. Let's see, what's 1,300 divided by 25? 52. So where's that page? There you are. So that becomes 52 over 8, 9.
Yeah.
And does 9 go into 52? 52 is
52.
13 times 4.
Well, no, I think 5 plus 2 is 7, so it's not divisible.
Excellent, that's true, okay. All right, so we have 52/9 there for the height. So now our volume equation becomes 1/3 pi r squared times 52/9 times h.
Times h.
No, r, other variable. Red alert, okay. So cleaning this up again, we got volume equals 52/27 pi r cubed, and we are ready to get the related rate equation. So we take the derivative with respect to time on both sides. So we get dv dt equals 52 over 27 times pi times 3r squared dr dt. Which cleans up a marginal amount because 3 goes into 27. Yeah, so we get 52 pi over 9 Let's see, we have to calculate R, I believe.
And then it's just half the diameter. Or is that a different R?
dr dt, something doesn't look right here.
Where did
Did
you
I
get the 27?
We don't
Mess
get
up.
27.
The
so he
27?
He multiplied the 1/3.
3
Into-
times 9 is
Oh,
27.
yeah.
Right there.
We have DHDT.
Yeah,
Not DRDT.
yeah, I think it's supposed to be a DHDT.
Oh, I don't think we were supposed to solve for.
H.
I think we're supposed to
Supposed to
solve
solve
for
for
I think we're
R.
supposed to solve. No, we solve. Oh yeah, solve for R.
What's the, oh, I
Because we
solved for the
already have
wrong
an H,
variable,
because we already
crap.
have an H.
Yeah,
Yeah.
oops,
Oopsie poopsie.
wrong variable. Yeah, because we need, because we have the HDT, we don't have the RDT, and we need dVdt.
So it should.
Darn!
Be two,
Okay.
Or it should
So
be
cancel all that.
9R over 52 equals.
All right, so, and just a good idea on a test, don't
9H.
erase stuff, just cross it out.
So you can still see it.
Yeah, because every once in a while, you erase the right answer. Don't you hate when that happens?
Yeah.
Okay, would give us credit if we had the right one crossed out.
You get partial credit. If you chose the wrong solution, I couldn't give you full credit, right? But if you had the right solution, they're crossed out. But if it's erased, I don't know.
Yeah.
You know. All right. See ya.
Yeah.
Okay, so I actually needed to solve this for R, not H. So in this case, I just flip it. So I would get, let's see.
9H over 52.
I want R, yeah. So R would be 9H over 52. That's what I would get. Which we have to square, darn. So I get 1/3 pi parentheses 9H over 52 squared times H.
52 times
All right.
2,704.
Oh my, how
Okay, go
exciting.
back.
So V
Oh, you're right.
equals,
You're writing it.
yeah, I was going to write it down. So let's see, 9 squared is 81 times 3. It's like 243.
1 times 3. Wow. Yeah.
So I have 243 pi over 52 squared.
Sorry. 2,704.
2,704, bummer.
I think times H.
Times H cubed.
Why H cubed? Sorry, I missed.
Because we have an H squared times an H.
Okay, yeah.
Do I
So
have
you-
my
you
pi
take
in
one-
there? So I have 9 squared, which is 81. Oh, why did I multiply that by 3? 3's in the bottom.
Yeah, so that's
Darn, I'm having all kinds of trouble today. Good thing I'm checking my work.
So it's 2,704 times 3,
Yeah,
which is 8,112.
3 times 2,704, which the 3 is going to cancel in a moment,
Yeah.
actually, so I'm
that's
going to
it
leave it like
squared,
that.
right? That's 57.
52 squared right there, and then 9 squared is 81. Okay, that's what we should have, right?
Sure.
Maybe.
Anyone else writing this down?
I'm
I
trying.
am.
I got it.
I'm
I'm
trying to.
confused.
Yeah, I
Okay,
need to simplify mine.
so let's see. 1/3 pi r squared for sure, times h. We use the shape of the cone to set up this proportion, which leads to r is 9h over 52. Yes. We plug that in for r and square it. 9 squared is 81, 52 squared is 2,704. Yes, okay, we're good. And then h squared times h is h cubed. So we have 81 pi over 3 times 2,704, which is the 52 squared times h cubed. All right, related rates time again. dv dt equals this constant, 81 pi over 3 times 2,704 times 3h squared, the h dt. The 3 cancels. That's about it. And then we can plug in stuff we know. Like we were given at a particular instance, wrong way, h is equal to 450 and dh dt is equal to 20. So then plug in stuff in. On one side, I've got 81 times pi over 2,704. H is 450 centimeters. squared dH dt is 20.
Oh, he gave us.
On the other side, we got to take that initial information about the leak, bless you, and solve for W. So the leak was negative 14,200 plus W. So dV dt is negative 14,200 plus W. So if we just add the 14,000 to the other side, we should have W. So W should equal all of that. So that right there is our W. Ooh.
Wait, I got a little confused.
Okay,
What did
where?
you get for 50 and 20 again?
That was the given information. So we were given
Oh, and
that when the height was that, the change in height was that,
Okay, I remember now.
and dV dt is always that. Yeah, so then I plug in that initial information. And by the way, this is like an area of math called differential equations, which some of you have to take someday,
Yay.
where all you do all day long is solve problems like this.
Wow, I did
Thank
that.
the
Kyler looks
Lord, I
thrilled.
never have to do this.
Okay, that was the funnest class I think ever for
The
me.
most fun, you meant?
No, I meant the funnest.
You meant the most fun.
Okay, I like funnest better. That's why I majored in math, not English. All right, so plugging that into a calculator. Let's see, does that seem reasonable?
Sure.
I think so.
I'll plug it in.
All right, let's use, do I need Desmos? Nah. Okay, so let me see, I had 81 times pi times 450 squared times 20 divided by 2704 plus 14,200, that's not a plus. If I typed it right, I get 395,339-ish cubic centimeters per minute, unless I mistyped it. Anyone else get that?
You typed that really fast. I don't know how.
Sorry, I'm used to typing things like this. I'm pretty sure I got it right. At least I'm pretty sure I typed it right.
Uh-oh.
So 81 pi, 450,
81 pi
20, all over 27
Oh, I
plus
typed
that.
that in wrong. Okay, I see. You put that on it.
Let me try this again.
And that
Thank
equals
you.
39,5339.
All right, Vitor matches mine. Must be right.
I got 865,302.
Let me say, it's not right.
169.
Or I'm not right.
I have different numbers than you.
Oh, okay.
I just did my problem instead.
Okay, that's fine. Then you could be right. So let's see, if I copy that. So on a test, the only way to double check yourself on this is just to review everything you did and say, hey, I think that looks reasonable. Oh, I got it wrong. Find the rate at which the water is being pumped into the tank.
So are we trying to find?
I got mine right.
Okay, so I must have an error somewhere.
You didn't put it to the 4 decimal places.
Oh, they asked for 4 decimal places?
Yeah.
I calculated AD for this one.
I put mine into 4 decimal places in it.
Okay, let's try 573. Oops. I'm just going to double check my work before I do that. All right, so we are losing
I did the same one.
14,200 cubic centimeters per minute, okay. And then water is being pumped in. The tank is 13 meters, which would be 1,300 centimeters. 5.5 meters would be 550 centimeters. Cut that in half for the radius, 225, okay. Looks right. Water level's rising at 20 centimeters per minute when the water is 4.5 meters, which would be 450 centimeters. That looks right.
Just plug in with the decimal places.
952. Yeah, I don't see an error at the moment. All right, more decimal places then. 8573. Oops, wrong button.
You deleted a number.
Nope, I have an error somewhere else.
What? I got mine right.
Huh.
Must be my work.
We
No.
don't have to solve for H or R, don't we? Because we already know that the height is 150 for mine. We know the height and then we know the diameter.
We know the height and the diameter, yeah.
If we do half of the diameter, we already have the radius. So we don't technically have to do H over R.
The problem is if you leave the R in there, you're going to get a dr dt, which we don't know.
Oh, okay.
Oh, we just said we were right.
Cool.
Will they be proportional?
I'm confused.
Given that the cross section is always a circle, I guess they are proportional.
Can you go back to your calculator?
You think I typed something wrong here? 81 times pi times 450 squared times 20 over 2,704 plus 14,200.
You didn't put your parentheses.
Is it
It's not. No, I don't need any parentheses. What's that?
Is it 14,000 supposed to go on top and then get divided by the number? Or is it
81
No, 14,000 is
times
after the division.
times 450 squared times 20 over.
Well, I think I'm right.
Think one more time, see what the right answer is.
Oh, fine. Let's see. Submit. And the answer should have been
Whoa.
583,555.
Actually, that does make more sense because my numbers aren't that off from yours, and mine's in the 8s.
So where did I make an error?
You swear? You swore.
I swore.
Sam, you're driving me nuts.
Okay.
Jesus.
Well, I will try it again later and get back to you all. I don't see my error right now. Let's do another problem.
Did you multiply everything correctly?
Okay, so
Possibly not.
you plug in DHT, which
And then you
is
solve for each.
you solve for.
Move 2 spots, so that's right. That's right.
Yeah.
Or, oh, I already have each.
Yeah.
So the next solves for.
Your H should
2
take half
becomes
of
a
it.
square.
Because it's-
450 is being squared.
Why?
Wait, go
And
back
that's
to the first page.
wrong number.
Hang on one sec.
Did you start
Just
solve
leave it
for R?
Okay, so right here.
Maybe not.
So I have
52 squared. Does that change anything? Same thing. Did I solve for R correctly? I don't know. Let's double check. Let's put a new page in between.
It's supposed to be 52.
196, which is squared of.
So the cone is 13 meters by 5.5 meters. But I'm more interested in the height versus the radius. So let's see, and I'm trying to solve for R. So R over H would be, oh, it's not 2.25. That's where I went wrong. It would be, no, 2.5, 2.75. That should have been a 2.75. Yeah, that's the mistake right there, over 13. I didn't cut 5 points, I cut half of, yeah, that's incorrect, right? Yeah, so this would be over 13. Okay, I see the mistake. So where does that fall in? That was related to the 9 over, yeah, so this 9 over 52 is where I went wrong right here. So that's the wrong ratio.
So it's 13.
Okay, so I can fix that easy
Why'd mine work?
because you divided by 2 correctly, whereas I did it incorrectly. Okay, so the 81 is incorrect. And what else? The 52 is incorrect. But that stuff, the 20, that's okay. So what I need in here is a times 3 for the derivative times 2.25 squared divided by 13 squared. That should fix it. Ah!
Where do you get 2.25? It's in.
What? Is it also wrong?
Oh, I did 2.25 again. 2.75. Oh, that's not right either. All right, apparently I need to start all
You forgot
over.
the beginning. When you multiply the number by pi.
There's pi.
Yeah, you're supposed to have a number with pi for yours.
Yeah, I put it over here instead.
Oh.
It's like, here's the moment of truth.
Huh.
So I got,
I said a poem.
You should have wrote down Desmos instead of Google Calculator.
Yeah.
I did it.
You get partial credit.
Okay, where would I have made a mistake?
Oh,
You get
the
partial.
1/3 cancels with the 3.
Yeah.
Oops. Oh, there it is. Oops. Okay, let's do a different problem. So let's see, what's next?
I have a stupid question.
What's up?
So when you're doing limits, like 1 over x, and you can't use a calculator,
Yeah.
how are we supposed to do
Sorry,
this?
that's my number.
Either you know it or you have to do it with a sequence of values. So for example, if you had something like the limit as x goes to 0 from the left side of 1 over x, you need to know one of two things. Either you need to know what that looks like as a function. Oops, missed a little bit there. Like that. So if we're approaching on the left side of 0, then y is going down like that. So you can say, oh, I know from the graph, that's my evidence right there, that it has to be negative infinity. Otherwise, you would have to make a table, x, y, where you'd pick numbers approaching 0 from the left. So negative 0.1, negative 0.01, negative 0.001, and so on. And you would see you get negative 10, negative 100, negative 1,000. And so you could say, yeah, this goes to negative infinity. Yeah, so you have to show one of those two things. So either this is your evidence or that is your evidence.
I still
Okay.
didn't get this right.
All right. What else should we try? Kyler, you got anything on your mind?
You do the numbers.
On the sample? Okay, so sample number 17.
0 pi plus the
Yeah. Okay, so we want to find the tangent line for this function when x equals negative 1. All right, screenshot. Okay, so this is number 17 on the sample final. So I want to find a tangent line. So the first step in finding a tangent line is finding the derivative function, which is the slope function. So let's see. For this one right here, I think I'll rewrite f of x by calling it 3 times x minus 1 to the negative 1. Otherwise, you have to use the quotient rule. And they both work fine. Here, I have to use the chain rule with the power rule. So f prime of x, the 3 is a constant. Constant multiple, it gets carried along. The derivative of this would be negative 1 times x minus 1 to the negative 2. Derivative of the inside is just 1. So cleaning that up, I get negative 3 over x minus 1 squared. Yeah, so now we want the slope of the tangent line. So to get the slope m, we plug in negative 1 into f prime. That gives me negative 3 over negative 1 minus 1 squared, which is negative 2 squared, which is 4. So I get negative 3/4 for the slope. I also need the y value to finish the equation. So y is going to be equal to f of negative 1, which is 3 over negative 1 minus 1, or negative 3/2. So then the tangent line using the point slope form would be y minus, be careful with your signs, negative 3/2 equals negative 3/4 times x minus negative 1. So when you substitute in, especially with negatives and fractions, use parentheses. So if I clean that up a little bit, first draft gives me y plus 3/2 equals negative 3/4 x. Let's see, negative times a negative is a positive, times another negative is a negative. Subtracting 3/2 to the other side gives me a tangent line of y equals negative 3/4 x. Let's see, how many fourths would that be? That would be 6/4 minus 9/4. And here decimals would have worked fine because 2 and 4 are easy denominators, but that's the fraction version. Those decimal lovers out there, it'd be y equals negative 0.75x minus 2.25. Oh, there's the 2.25 from earlier. And then I have no idea if I screwed this up. What should I do to check?
Plug it in.
Yeah, plug it in the decimals. Graph this, graph the tangent, see if they're tangent at x equals negative 1.
So the tangent line would be the y minus 4.
This would be the tangent line, yeah. And on the test, I want you to make a hand-drawn graph of this, right? If I ask for that, there's going to be at least one graph on the test. So I'm going to do a rough sketch of this graph and the tangent line. So let's see. Let's see, was x minus 1? Is that right?
Yes.
Let's see. 3 over x minus 1. Okay, so 1. So that means there's a vertical asymptote at x equals 1 that it can't cross. And then if you know what y equals 1 over x looks like, then this one's pretty similar. It's just 3 times that and shifted over. So 1 over x would have had a point right here, but I'm going 3 times that. So let's see, that would be right here. So, and let's see, I want at negative 1. Okay, so at negative 1, what does that look like? There should have been another point over 1 down 1, but I get 3 times that. So there's going to be a, I'm trying to graph that function by hand.
What numbers are you
17.
Is it by?
I'm plugged, so far I plugged in 1 and negative 1 into it. No, 1 and 0. If I plug in negative 1, I get negative 3/2. That'd be about here.
Wait, what are your space? What's the factor for the
That's what
spacing? Is it by 1 or
This
is it by?
is 3, 3,
Okay.
negative 3, negative 3. Yes, I'm scaling by 1. Sorry about that.
I didn't
Y. X, yeah, on the test, make sure you give me numbers so I know what I'm looking at. And see if I plug in negative 2, I should get negative 1 about right there. So that's this function on that side. And on the other side, it does something like this. And then my tangent line is right at that point right there. And what was the slope? Negative 3/2. So if I go up 1, 2, 3, then I have to run 1, 2, 3, 4. All right, let's test out this tangent line. Where's my line tool? Lines. Not too bad. Make that a different color. Make you red. All right, so that's what I think it looks like in my hand-drawn sketch. I really should have gotten Desmos out sooner, but I was feeling a little sassy. So let's get Desmos to double check that. You guys probably already did. So I have f of x equals 3 over x minus 1, right? Yeah. And I need a point, negative 1 comma f of negative 1. And I'm using Desmos to check that I calculate that right. Negative 1.5. Yep, that's what I found earlier. And so then y minus f of negative 1. So I love that you can use function notation in Desmos. Equals negative 3/4 times x plus 1. Yeah, that's not bad compared to what I tried to draw. Right, look at that. And look at that. Oh yeah, look at that. Identical match. Woo!
When it says like graph it, are we gonna be able to use our graph to kind of check our own graph or no?
Yeah, you can use a graphing utility.
We'll just have to put our points on it. Like,
You know what I had a student once
What?
do? They tried to, it was on a TI-84, they tried to take their piece of paper and sit it on top of the TI and try to trace through the paper, the graph underneath. I thought it was pretty clever. It was a little awkward because the screen's indented on the TI-84. Yeah. All right, I got a few more minutes. I got enough time to do one more problem, and then I got to get to a meeting at noon. You want to take the test today? Yeah, you can. I have it ready to go.
You are crazy. Oh my God.
Take it to
Yes, Sam got his right.
Right. What were you doing? The graphing one? Or no, something else?
That's doing the cone one still.
The cone one. Oh, good. That's a tough problem.
I forgot.
So just let you know, one thing I did take into consideration when I was writing the test, because related rates problems take a long time, like that one, and so do optimization. When I chose the problem, I chose it based on the average completion time of students doing it online.
Oh, but that.
So for example, I didn't pick a problem that average student time was like half an hour.
Okay, but then again, you can't say that because there's videos on some of them, so the time is going to.
I know, the time is a little skewed. Yeah.
Except that soup one, that literally, there's a video with that one and that took me a good.
Well, and some of them had
my
multiple
gosh.
steps to plug into,
No, the
whereas
video
others
doesn't
were just
work.
give me an answer.
The video doesn't.
Well,
talk
it's not
about
that the
soup.
video is right, it's that on the actual question, there's. only
One more
two
question.
ways for the-
Kyler, what are we gonna do? You don't know? Okay, I get to pick
Can I
that.
look around a little bit?
How about
There's one that I-
Highway Patrol? No, I did. I already posted my solution to that one.
These are just like let's do.
Okay, let's do the open top
derivative.
box
Let's
then.
do a hard
The open
derivative.
top box was easy.
Yeah.
Oh, that was easy?
Wait,
Okay.
it is.
Yeah,
The open
'cause-
top box
Okay,
was
oh, we
easy.
should do the quotient rule on this sucker right here. That's a hard derivative.
Yes, let's do that.
Okay. So does anybody know how to try to avoid the quotient rule? There's like two ways.
You multiply.
You could multiply by a thing with a negative power, right? Or you could, if it's a problem like that, you could try doing synthetic division. Isn't that what we tried the other day? Yeah. So it turns out for this problem right here,
This is 22.
It works.
there's like 3 different ways to do it. But we're going to try this by using synthetic division.
We have
No,
it. We have
the quotient rule. Yeah, let's do the quotient rule. So this is f of x. That's supposed to be an x there. Yeah, so it's low d high minus high d low all over low squared. Okay,
I
so
think
low
plus.
is x plus 1. D high would be 2x plus 7 minus high x squared plus 7x plus 10
D low is just 1.
times d low, which is 1, which you could feel free to leave that off. All over low squared. And sometimes, but usually not, yeah. So then we have some distribution to do here. And distribute the negative sign. So what do we get? We get 2x squared, and then we'll get a 2x and a 7x, so a 9x plus 7 minus x squared minus 7x minus 10. Be careful with your signs. All over x plus 1 squared, which gives us x squared plus 2x plus minus 3. Thank you, keen-eyed Sam. Is that right? Yeah. All over x plus 1 squared. And that might
It's
factor.
X plus 1, X minus.
as x plus.
X minus
X
one.
plus
No, it
one.
doesn't.
No, it's x minus 1.
X minus
Oh,
1,
that's
X
sad.
plus 2.
X plus
X
3.
plus 3.
Oh, yeah, you're right.
All over x plus 1 squared. Yeah, so it doesn't factor. But if we had to find critical points, which was the next step, factoring the numerator is kind of nice. Because now I know critical numbers would occur at 1, -3, and at -1. Kind of, yeah. That could be a change in concavity, but it won't be an inflection point because the function's undefined there. But it could be a change in concavity because the second derivative will be 0 there too.
Oh. I was like, what? Where are we going?
All right, we're out of time
so-
for fun
I'm
with math
so
today. I'm
just
so
like-
sorry.
My brain was